So I'm working on a project called it's a PID controller, or a PID controller, and it's a very common system used all over the place, but it's probably be called maybe an automation algorithm. But essentially, it works by trying to compensate for environmental factors in order to maintain some set point. So like if you want your house to be 72 degrees in the summer and the winter, then of course the system has to adjust depending on what the environment is like, if you want the temperature to always stay the same. So as a very basic stripped down example, I have a light, just a little LED shining at a light dependent resistor, which is a type of light sensor. And the brighter the more amount of light striking the sensor, the higher voltage will be produced on the sensor. And you can see whenever I begin to interrupt I put a piece of paper between the two, the LED will increase brightness in order to make sure that the same amount of light strikes the sensor. So at the moment I am working on something called a PID controller, PID, and its purpose is in automation or just controlling devices. You're trying to get a output of some kind to match up with a set point, a control. So giving a real example, if you have a so you have a motor you want it to spin at exactly a certain speed, and you could have a dial that you would adjust to set the speed, and then you would have an encoder or a speed sensor of some kind that would monitor the motor, and you have to have some kind of smart control electronics that would be able to adjust the speed of the motor whenever the input changes. And for example, if you were to grab the motor and force it to spin slower, then the control electronics should know that it has to increase the power to the motor to keep it going. So what I have here is a very simple setup. I have my output device is just an LED, so it will light up red, and then the input device, or the sensor, is just a light dependent resistor, and I'll have a set point, so I can adjust how what I'm going to do is adjust how much light I want to hit the sensor, and then the Arduino board will change the brightness of the LED to try to make sure that no matter what happens in the environment, the amount of light striking the sensor is as close as possible to the set point. And this can get pretty interesting. So the next thing I want to show you is some of the behind the scenes data. There are 3 lines that are potentially important. The first one is the red line, and this is what I call the feedback line. It is, or maybe the sense line. It's actually just a value of the sensor. So ignoring the other lines, as I wave my hand over the sensor, you can see that the red line drops, and that's because it gets darker. The second line is the blue line. This is the set point line, and by spinning the knob, I am able to bring the set point up and down within the range. And the third line is the green line, and that represents the actual brightness, current brightness of the LED. It's at 0 right now because it's off. So now what I'm going to do is bring the set point above the current brightness of the LED to try to get it to turn I'm going to bring the set point above the current reading of the sensor. So right now the sensor is reading around 160, we'll say. No, that's probably closer to 180. And I want to make the sensor read 200. So I will bring the set point line up until it reaches around 200. And now you can see the LED has turned on to increase the brightness of what's striking the sensor, and the reading of the sensor is hovering around 200. It's pretty cool. So it's operating, and what happens if I say wave my hand over top? This is going to make the light from the room not strike the sensor, and it's going to force the LED brightness to increase in order to maintain the same amount of light striking the sensor. So you can see as I move my hand above, it actually may be difficult to see. You may be able to see it on camera, but that LED is getting brighter whenever I wave my hand over it. Another thing I can do is take a piece of paper and try to block the sensor. And if I cover up just a portion of the LED, then you'll see that the LED will increase in brightness to compensate for the fact that there's an obstruction in the way. And you can watch on a screen that the green line jumps up when I move the sensor, or I move the piece of paper blocking between the light and the sensor. And so this is a very simple application of a PID controller that it's one of those things that shows up in all kinds of places. If you have a remote control helicopter or a quadcopter, in order to get it to balance in the air, it's got to, the set point of course would be that the aircraft should be flat, and the actual reading comes from accelerometers and gyroscopes on board, and then it uses the output to the motors to try to adjust the sensor reading until it reaches flat. And it's actually a very similar algorithm that I'm using here that you would see in like a quadcopter or something. Another would be, say, a thermostat in in your house, or heating trying to get a heater up to a certain temperature and staying at that temperature. So in that case, the output device is the heating coils. The sensor, the input device, you'd have to have a temperature sensor, and then the set point would be like 300 degrees or something. And in that system, if you were to throw ice on the heater, then the temperature would begin to drop, and the system would automatically increase the power to the coils so that it would bring it back up to the set point. So it's a very powerful system because it's self-adjusting and self-correcting, and it's able to deal with an environment where things are rapidly changing, and it's able to maintain the set point amidst all that. So very interesting, and just excited to see what else I can kind of do with this project. So just thank you for watching. Hope you enjoyed this little demo. See you next time. I wanted to see how well this system handles change. So as a curveball, I turned the lights off, and I have the set point fairly low, so only a small amount of light should be allowed to hit the sensor. But whenever I put this piece of paper in, you can see that LED gradually got brighter depending on how much of it I block. And of course that's because only a fraction of the light is able to pass through the white paper, and so the LED, in order to maintain the same brightness on the sensor, LED has to get a little bit brighter.